We want flamethrowers, precious. He wants DMX control the flames. No, Gollum, no, we can't. We can't do that. It's not safe. It's not hobbyist appropriate. It's not really what I want to do here. No, he wants the flames. Even the cookie wants it. This is not picky. Gollum, why do you sound like Kermit the Frog who needs a lozenge? Just how I sound. I'm just choking on something. I'm having too much fun. I am also having too much fun. Good evening, y'all. Welcome back to another very goofy Sunday night. Sorry for the spooky intro. This was something my wife left for me on my workbench earlier this week, and I'm not exaggerating when I say I nearly crapped my pants. So this is going to be our little friend for the evening who's going to, sort of constantly be the proponent of bad ideas, of which I'm sure there will be many to go around, as we talk more about things in scale moving light hardware. Wow, that's just my whole hand right there. Now, little Gollum is surrounded by, circuits and other productive things. We'll just put him off to the side here. He can continue to be a bad influence as I do just a little camera adjustment. Hello, it's nice to see you all again on a Sunday night. Brooke, both Thomas, hi, good to see you as always. Yes, we're going to talk about some potential ideas for a next project. Now that the tiny Kabuki Drop is sort of well in hand. I mean, it's not done, right? It's never really going to be done here. I could get the view of that over here. Yeah, so I haven't even rehung the curtain yet from our experiments last week. Hey, Francesco, yes, happy Easter all. Yeah, it's going to be a goofy night, y'all, for all the better reasons. So I think the theme of tonight is going to be figure out what sort of the next chunk of project is. I mean, obviously, there is more work to do on the tiny lights front themselves. And so I think the busy work of tonight is going to be just me assembling some more of these, the version 0.96 lights. Just because, I mean, frankly, the inventory in the microstage, well, I think there's 2 lights here, and neither of them are currently hung. So it's a little bit barren. It'd be nice to start getting some actual, lighting fixtures in the rig. So we'll just build a few of those. But while we do, when I sort of muse through with y'all the variety of awful ideas that I've had for what, the next sort of creative project would be. Because the Micro Kabuki was super fun and different and, had a lot of parts that needed figuring out, so this mechanical adapter properties that Thomas chipped in on and provided the coupling for, what is the mechanism of the drop, what is the 3D printed part. So that was super fun, and so I'm thinking about other things that could be sort of in a similar vein to be another small mechanical component of a tiny moving light system. And I think potentially the answer is, I don't want to salt anything too soon. Maybe it's something that allows us to move a lighting position up and down in space under some kind of external control. And we'll sort of leave it at that, because there's lots of different ways we could achieve that. And that's kind of what I want to do tonight, is a little bit of spitballing where I'm thinking that might go and hear what other people think might be good or, frankly, bad ideas, because I think that'd be a lot of fun. I guess the only other point of business is tonight's beverage of choice is a Bell's official from Bell's Brewing Company here in Michigan. It's a hazy India Pale Ale with a lot of juice, and it's just real tasty. As always, if you're drinking something tasty, hi Dave, good to see you. Next chunk is fire, says Dave. Yeah, exactly. If you're drinking something tasty, always curious to know. Water also always a good choice. Hydration is good if drinking is not your thing, or if you're just like, I could use some water. And that should be all of us more often, really, right? We should all drink a little bit more. Yeah, a DMX scale pyro component. I don't know that that's a great idea, but it is an idea. I mean, we could go down that rabbit hole. But I mean, there's any number of reasons why DMX control of fire is a bad. Let's see. I was just gonna pull up build instructions for the Demilight, which are conveniently at jeff/glass/demilight/build. jeff.glass/demilight/build. Which is the build instructions I've been following along. Frankly, this is one of those things, it took a while to put together the documentation, but, it's become so self-reinforcing. I don't remember where I stopped, but I bet I can figure it out just by looking at these assembly parts. I started these, so I'm hoping to get 3 lights finished and assembled tonight. I'm hoping I can figure out which step I left off on by just looking at where I was. Let's see, some small stage automation would be cool. A rotating platform or something? Yeah, that would be cool. Yeah, I feel like So like the micro Kabuki drop, just thinking about it as like a starting point in terms of the mechanics of it, like the actual things that need to be controlled. We have a relatively low weight axle, and we have servo motor control. And for the Demilight project, right, those were both solved problems. Which is partly why it was a really good sort of first small mechanical project for me to take on, right? Is like it didn't have that much going on electrically, and so that was nice. I think for the movable batten hardware, whatever that ends up looking like, as Thomas says, steppers is probably going to be the way to go. Maybe a continuous rotation servo, although at that point it's kind of just like a stepper. There's some considerations in terms of like thinking about like the brake mechanism. Dave, that's a good question. Are we sticking to the theatrical realm or expanding? Not sure. Did you have a thought if the answer is one way or the other? To be honest, I was just kind of looking at like what we have in reality at the moment and thinking about what would be a neat addition to that. Sort of building on top of Cookie's D3D trust system here. But we don't necessarily have to stick to something. It would be nice if it was something that would sort of start integrating into that hardware space, if that makes sense. And Dave, that's a very fair question. Do we want to focus on programming / Arduino or mechanical? Either or. I suspect whatever comes next will probably have some of both. Certainly in like integrating a stepper motor control and thinking about, maybe thinking about limit switches. Not that that's a terribly complicated project to solve, but like, I guess that's what I'm excited about these days, is thinking about some like the mechanical interactive projects. I also, to be totally candid, because, we're all friends here. Anyone who's like lurking out there, even if you don't feel like chiming in the chat, we're friends too. It's nice to see you. The Micro Kabuki project was a really fun thing to do on stream, partly because the miniature mechanical nature of it made it really easy to work out an idea, have y'all people tell me what I was doing wrong or how things could be better. We could 3D print 2 or 3, maybe 4 iterations of a small part in an evening, and doing that kind of rapid iteration with y'all was super fun and cool in a way that like, the Arduino and the circuity stuff is also cool if it's just software, but the iteration time for, turning something like a new circuit board into a board is about a week. And that was the cycle we were on for a long time, right? We'd design a board, I'd get it fabbed, and a week or two later it would come back, and I've kind of fallen off of that speed of progress, although really I should get back on it. Yeah, I don't know. There was something I'm just enjoying the process of like revising a mechanical project over and over until we could sort of have something working that night. I like a one-day project. I was just talking to my wife about this the other day. Actually, Mary has some input on what we should be focusing on. Her I don't know if you can see the whiteboard back there, nice and big. Excuse me. She says no fireballs, 0. So that's her vote. And she's, maybe no intentional fireballs is a good goal for us here this evening. But, ooh, yeah, Tom, we could invest in a PCB mill. At some point, I'm just gonna run out of space, right? I still need to find. Oh, I should have brought it in with me. So that I still haven't mounted the new light board in here somewhere, and I need to find space for that. And it's all feasible. It's all possible. But yeah, like. Here's a good question, Thomas. As I look over here and try and find my place in our assembly instructions, so for something like, this is an 1.5 square PCB, for example, with some relatively small traces. I mean, you've seen that design. How long, in your estimation, would the setup and milling for a single board of that size be? I just don't have any experience with PCB mills. I have a hard time telling if there's like a little static on the mic tonight. Feels like there might be, but I can't. Oh, you know what it is? It's my cell phone coupling into the mic pickup. Just set that out of the way. Let's see. So these of course are still the build instructions for version 0.94 because it still has the threaded inserts, which we've done away with, which is very good. So I think we're on this step where we're doing, oh no, that can't be true. So here's the attach pan servo to lid, and the modules that I was working with, I've already done that, so we have to be past there. We must be on, yes, onto PCB prep. I think this must be where we are, where we do the through-hole parts, and we'll do the regulator, burn the bootloader, and upload the code. And then we'll be kind of close to the end. So this is good. We actually have a fair amount of the assembly already done by a past me. So thanks, past me. So part of the challenge here is parts are challenging to come by these days. So I am a little bit short of new in-bag parts. So a couple of these parts we may have to salvage from other things. Let's see. This is an older generation of board. This is a 0.96 board, this is 0.96, and this is a 0.96, yeah. Berkwood has a question. Are those PCB mills economical now? Last time I looked, the cheap ones weren't very good, and the good ones were a couple grand and up. Yeah, this is, I guess, you know, to like, y'all have heard me gushing about the, where is it? It's over here. The Prusa Mini, right? The Prusa Mini Plus now, I guess they're selling it as, it's a great 3D printer, and it succeeds where my 4-year-old printer never did. Is that it really is with just a little bit of babying, fire and forget. You know, you keep the the print surface clean and try to keep your oils of your hands off of it. You know, clean the nozzle in the bed every once in a while, but like the mesh bed leveling and just the general quality of it makes it really easy. That's kind of what I would want in a PCB mill, and this is just my personal viewpoint, is I'm not necessarily interested in making a hobby out of refining the operation of a PCB mill. I want to have PCBs, right? I want to, and that would be what I'd be willing to pay for, and up to a limit, because, you know, it is just a hobby after all. Let's see. Thomas says a one-sided board super slow that was bigger was 20 minutes. With a jig, you'd probably two-sided in 20 with some practice. Though, so operationally, that's a lot faster than I would have guessed. So that's quite good. Yeah, I don't know what the go. I mean, certainly we've all seen, or maybe we haven't all seen. Maybe we should pull up the like super cheapy, undocumented. You know, the equivalent of the no-name 3D printer from AliExpress or eBay or what have you. Let's see. Yeah, one of these like 3-in-1 laser engraver router CNC miller. Yeah, this is not, of course, actually $46. That's just for the accessory parts, right? So if you want the actual thing, I could do it with a laser head. I don't know that I would etch a PCB with a laser. That seems like a recipe for disaster. But it's essentially, right, it's like a 3D printer with a little bit, probably with a ball screw as the lead component, as opposed to an elastic band, right? Because you need some mechanical rigidity. So here's like a no-name one. Here's a Fyongsake brand one for $200, right? So that's our bottom of the barrel, and I can only imagine it would go up from there. Thomas is using a 3018 prover, and 3018 in this case I think is like 30 centimeters by 18 centimeters etchable area is how these things are named. 350, annoying part was cutting PCB, which I did wrong, so I had to sand it a long time. Yeah, because I imagine especially if we wanted to jig these, we would need to. Now, I guess, well, I was gonna say, if we were gonna, there'd be ways of automating that too, right? Or just ordering PCBs to a certain spec and then etching them afterward, or milling them afterward. That might be kind of interesting. So that could be in my future, although certainly I've no dearth of projects right now. So maybe that will be a thing. But why don't we start getting some through-hole parts into these PCBs, and we can continue to figure it out. I mean, honestly, the other thing that's going to sort of stymie PCB development is the massive shortage of every kind of integrated circuit in every market right now. Is absolutely awful. Oh yeah, Thomas, I'll hold your questions for 45. Go enjoy yourself. The number of times in the past couple months that either friends that I have who work in various industries or my job at the museum, we've run into like very unfortunate, very long lead times for things, just because oops, sorry. I popped my lav mic off of my shirt. I'm gonna mute myself while I clip it back on. So I had forgotten. So I can mute. Let's see. Are we back? Are we back doing a thing? I think we are. Let me check my levels. There we are. Testing? Yeah, I think we're back. I had forgotten, so I can, of course, mute. As you all well know, I can mute the microphone so I can fiddle with things without worrying about it too much, but I had forgotten that doesn't actually mute the monitor that goes into my ears, and so I just had a really pleasant 30-second sonic experience of fiddling with my microphone as it ground across my eardrums. What were we saying? Oh, component shortage. I don't know if this is something that y'all are dealing with. I know we're in a lot of different and disparate industries and hobbies and professions and things. But it's wild out there, y'all. Everything from, so I have a friend who works in the crib, in the cage at an auto plant down in Louisville. And they mostly, I think, are doing like large-scale fabrication, so making like panels and chassis and frames, like they're like a machine shop. But the two primary auto plants that they support down there have had to cut capacity by like 80% just because they can't get the chips that they need, and their suppliers can't get the 17 chips that go into an automobile headlight these days. And so that's trickling up and down the supply chain in both directions, and it's really quite bad. We ran into this at the museum just this past week. We're nearing the finish line on revamping. So I think I mentioned before, we have a 727 airplane from the 60s that got installed, cantilevered out from our balcony in the early 90s, and we are currently doing a giant overhaul of all of the interactives, all of the graphics, the carpet, the chairs, like really spiffying this thing up and making it look good. And part of it is some of these graphics have big purpose flat LED panels. If you've seen like LED tape, the thin substrate LED products, similar idea, except instead of being in a 1 centimeter form factor, it's in like 18-inch panels that's meant to very smoothly, you put it an inch behind an acrylic graphic panel and it lights it very evenly, right? That's the whole point of the thing. And they are having huge lead time issues. We're supposed to be getting those panels. Those panels are currently scheduled to show up 2 weeks after this exhibit opens or something absurd. So yeah, it's rough out there. So all this to say, this is something that's very much on my mind as I'm thinking about doing PCB revisions. Right now, I'm sure you're getting a lot of that juicy crinkle that y'all come here for. A lot of the parts that I would put on these boards, especially the weirder ones, things like the AL8860 or AL8861, which is the LED dimming chip, which in normal times, I don't really understand how JLC PCB chooses to stock things or not, because I've seen them, stock anywhere from a couple hundred to a couple thousand of each of those, right? Which, for my purposes, is fine because I only need 10 of them at once. But right now there are zero AL8860s and I think 9 AL8861s in all of JLC PCB stock, let alone what they're willing to allocate for surface mount assembly. So it's kind of wild out there. The thing that was floating around Twitter the past couple days in some nerd circles was the term of art is designed for manufacture, right? As you're thinking about making your product, you should be thinking about how it's going to be assemblable from the very earliest stages of design. And that's everything from if I'm using 5 types of resistors on my board, that's 5 different reels that have to go into the pick-and-place machine. Could I redesign it so it only uses 4 reels, right? Could I use 2 5K resistors here, because I'm using them elsewhere, and scrap the 10K resistor reel entirely? In circuit terms, that's often what it comes down to is component size and reuse. For what it's worth, speaking of component reuse, because my shipment of Phoenix terminals hasn't come back yet, I'm going to strip a couple of these, the solder and Phoenix headers off of these old dead boards from that's a version 091. I don't know what we did to kill that, but I'm going to steal the connector off of it. So there's this idea of design for manufacture, that you consider the costs of the choices you're making and try and take some good practices in component unification, in component sizing, in how simple is it to actually put the parts where they're supposed to go? Can you adjust the housing or the case to make it simpler. And now the sort of word on the street is you should be designing for availability, right? You should be not designing necessarily for just what's easiest to manufacture, but designing for the parts you can actually get on the market these days. And if you're going to like start that design, you buy those parts right now, put them on your workbench, and then finish the design, and then order the PCB, because by the time you finish designing it, those parts might be gone, which is just a wild way to work. So like I say, I don't know if anyone is experiencing this in their own lives and hobbies, but it is pretty wild. Who's the director video of the live stream? It's me. it's your boy, Jeff Glass. I just use a little, I do this every time, so I heat up my iron without checking what tip was in it. I have this pencil tip in, and I really want my chisel tip, so I think I'm gonna do a little hot swap here. And by that I mean literally a hot swap. I'm gonna turn the iron off and I'm gonna use a pair of pliers to take that old tip out and put my nice chisel tip in, because we're gonna need to dump quite a. Oh, that's a broader pencil tip. What are we gonna? Oh, here, chisel tip. I could even use actually a bigger one. Maybe I'll get this guy out. So is that gonna be too big for our purposes? It might be. I don't want to do these. Yeah, I'll do the slightly smaller size. Toss that back in here. Let's see here. Francesco, why do you ask? Is there are things going sideways? They sometimes do without me noticing. Partly just because I try and not look at, like, you know, the stream parameters while I'm streaming, because I get distracted, because I'd rather be focusing on y'all. How do you change cameras? So this is a great topic to be talking about while changing tips, because that's an easy task that y'all have seen before. So I am using, here's a little how the sausage is getting made. I am using OBS's open source streaming software, OBS Studio, which has multiple scenes. So I have a scene set up for this view, and I have a scene set up for this view, and for that view, and whatever. And then I'm using Elgato's Stream Deck product, which is basically 15 reconfigurable soft keys with an LED screen built into them. And they're pretty programmable to sort of do whatever you want. Especially there's some pretty tight integration with OBS. So things like changing a scene, muting or unmuting a microphone, playing back a piece of content, you know, basic stuff like that is really easy to do. And you can also just use it as a general hotkey machine. Like if you wanted to have it type a hotkey, or you wanted to configure it to work with like Fusion 360 or Microsoft Word or whatever, it can just do native hotkeys. But I primarily use it for streaming. There's the Stream Deck. Or VS Code, which it doesn't have, you know, sort of native integration with, but like I say, it can just, you know, act as a macro keyboard. So I have a button that's set up when I'm in VS Code to hit the command for like collapse all sections of code, which is something like Control K, Control apostrophe, which or something like that. I can never remember. So I made a little hotkey for it, and now I don't have to remember. And that's the kind of stuff that this is good for. So let's see if we can't salvage a couple of these connectors here while we do it. But yeah, so that's how I stream. This all started with a long rambling tangent about the shortage of semiconductors and how it's affecting, you know, various industries. It's also, my experience in the past couple months is it's affecting every industry a little bit differently. So like, for example, we're, you know, this overhaul of the 727 in the museum that I mentioned, we're doing not a full overhaul of like the lighting system itself, but an overhaul of the lighting control system, including, there's my dog Winnie having some feelings, including some dimmers, some control systems, and so on. I was chatting with one of our consultants the other day, a really great local guy. We worked together before. I was like, oh, hey, how's that big project going you've been working on? And he was like, dude, it's great, except we can buy, a $40,000 lighting control console, but we're having the darndest time getting the $200 dimmer modules that go in the dimmer racks. I think a lot of the folks who are on this call have theatrical lighting experience or theater approximate experience, but for those who don't, the contemporary model of stage lighting dimming, making the intensity of a light change, is often a number of electronically controlled SCR dimmers, triac dimmers, mounted in a big old vertical rack. Not like an IT rack, although the concept is the same. It'd be a vendor-specific rack that holds a number of these modules, and each one is usually two dimming modules, 2 triacs, and a choke to smooth things out, and a little bit of control circuitry. And then there's one central processing unit, often in the middle of the rack, that takes DMX and turns it into whatever sort of subsidiary control signals the individual dimmers need to do their thing. And so apparently whatever shortage, so there's only a couple companies that really make these things for the market anymore, and so I didn't necessarily name which one is having these shortages because it's all sort of hearsay. But apparently, like the materials for the main processor unit, like the central processor unit, are still coming in fine. But there's some components of the dimmer modules themselves that are really hard to come by. So yeah, it's a wild world out there right now as far as parts availability. So we'll see how this all shakes out. I hope y'all are still doing well out there in your own places and countries, and things are still looking up. Things are looking okay here in Chicago, COVID-wise. About as good as they have been, and our museum is open with a limited capacity in a pretty safe way, and people seem to be doing pretty good about leaving their masks on and washing their hands. So I'm hopeful that this is the final push towards sunlight. But now we get to see the fascinating ramifications of an interruption in the global supply chain. Francesco, yes, I know our native languages are not the same. So yes, I hope someday that they do. I think someone told me that Google's Pixel earbuds, Google's answer to Apple's earbuds, has a Google Translate feature built right in, which is fascinating. That's like living in the future. What's not like living in the future is desoldering these Phoenix connectors. This is not going well at all. You know what I might do, and I know I don't pull it out very often, so I'm not actually 100% sure where it is pull out my solder sucker. Where would it even be? I think I've said before on the stream, I don't typically use a solder sucker. I find solder braid to be pretty sufficient for most of my purposes, but here we have a situation where, and you get a little top of head cam, in the meantime, where I've got a through-hole part that is encrusted with solder, and it needs to come off. Maybe a little extra flux on it as well. That'll help. There are services that do live stream. Put the PCB in your PCB holder. Potentially, I'm actually kind of liking having it on the desk for now so I can really grind away at it, because this is a PCB I'm not going to care about once I get this one part off. Let's see here. Let me just flux this up a little bit more. If we totally crash and burn on this, I do have at least one spare floating connector here. Actually, maybe two. So we could carry on building that once we get tired of watching me, struggle with desoldering this component. I don't have a hot air rework station at home, but I do have a hot air gun that we could use to pull this off with, although the nozzle is very large, so there's a good chance of some fire happening, which I know is not a downside for everyone. Yeah, one of those Heiko desoldering guns would be really nice. It's funny, Broke Both, we were, as we were saying earlier, the differences between the good version of something and the cheap version of something. At my last job, we had a little room in the budget at the end of one year, and we got the cheap version of those desoldering guns. So, the Heiko desoldering gun, I think, runs for $300 or so, $250, and this was the $140 version, and it was not even worth that. the solder would collect in the vacuum material really quickly because the filters were crap, and it was just not. It was not a good scene. So if something like that worked would be awesome, but I don't. Oh, you know what I do have? It's not really the right tool either. I have desoldering tweezers, but as a 4-pin device, I don't think that that's really going to help me here. I guess I could do that and the soldering iron. I'm actually kind of surprised. Oh, you know what it is? They're all pretty much free, except, of course, this last one is the ground pin. And that's connected directly to the ground plane, and that's why it's being such a pain to dump enough heat into it. Even with my iron turned way up hot, it's just not wanting to come free. Let me give it one more good crack, and then maybe we'll go on to assembling the first one. We can always come back to monging this later. That was promising. Yeah, just a little burn there. It's fine. I do actually. Speaking of burns, I have a really juicy one on my forearm there. You can see a real juicy pear. That's actually it's fading quite nicely, but I was up in the ceiling of the museum the other day, and so maybe a couple weeks ago now, maybe even 3 weeks. What time? And I was needing to focus a Source 4, a theatrical light, on. It had been on for 4 hours by the time I got up to it, because it's, a lot of our lights are on 24/7, or whenever the museum is open, and I positioned my arm just wrong, and it got me. It bit me a little bit, and that just comes with the territory. But let's see here. Will you? Yeah, it's this ground plane. I'm really struggling to get enough heat in there to get this free. Ooh, there's something that's really crackling there. I assume it's crackling for y'all too, and it's not just me and my headphones, but I think it's my microphone crackling. Well, I'll tell you what. Why don't we punt on this for now, and I'll move on to assembling the one with the the component that I do have, and that will be certainly more interesting to look at, I suspect. So let's see. So I've got the Phoenix connector, I've got the PCB, I've got the switch mode power supply. I'm gonna need some header. Get our bin of header pins. Those are the extra long ones, like if you're doing mating a female header and a female header together, or doing it into breadboard. This stuff is really nice for breadboarding, but what I'm going to use tonight is the long into short stuff, because I only have to go through the PCB a little bit here. So I need a 1x6 section for the programming header. That's 1x7, so we'll snip off a little bit there. And then we'll need we'll need a 2x3 section, or if I ask, we'll do two 1x3 sections. And that'll be for our ICS. Oh, actually, we don't need that anymore, do we? Because we have our pogo pin jig. All right, well, those will go back in the bin for another day. Oh, but I've thrown those away now. I do need those two 1x3s for the servo connectors. So, good job there, me, figuring it out. So let's get those soldered in. So I'm gonna start with, I think, the programming header. And you'll recall, a little bit of extra tape there, just peel that off, that while these used to be only programmable by an ICSP header directly into the ATmega, that as of the big change in version 0.96, and you know what, Dave, to your point, this is where I'm going to pull the PCB vise out, because that will make this easier. The big change in Demilight version 0.96 was adding this 6-pin header that is programmable with a standard sort of Arduino-y FTDI adapter board like you would use in an Arduino Pro Mini, just because that is a little bit easier for me, and I figure a lot easier for most other folks. I'm going to zoom out just a little bit, and we'll put the headers in here. Grab a little blue tape, and we'll start this soldering. Ooh, I can see I'm gonna have to. Oh, you know what I should use is the 6-pin section. I don't have alignment issues there. Stick that through, tape it down. Okay, well now after I'm through the odyssey of trying to desolder that thing that was not going very well, maybe we can return to the conversational topic of tonight, which is the next piece of theatrical hardware that we want to build. And so I have been thinking about, and I believe, I don't know if Cookie is with us tonight, but I believe they have been thinking about a 3D printed miniaturized chain hoist or winch system. And I don't want to step on any toes, but it's also like a really exciting prospect. So maybe two solutions are better than one. And I mostly because we have truss and we have light, right? I think it would be a fun addition to be able to, raise the trusses up and down for, like do a little focus call where the trusses can move and also, I don't know. There's something about it that strikes my fancy. So that's where my brain goes. But somebody, maybe Broke Both mentioned earlier, maybe thinking about a revolve or stage scenery. I forget who said that in the chat earlier. But that's a cool idea, doing some other kind of... I guess I haven't really thought about any kind of, like, stage scenery, right? I was thinking something that was more integrated with, like, the fly system or the truss. But doing something that's, like, starts to really flesh out the idea of a stage is kind of cool. Let's see if I can straighten this out without burning myself. Just... doesn't have to be perfect, but it'd be nice if it was a little more flush than that. Yeah, there we go. That's pretty good. A couple of servo connections. Dave is something. How about something with audio? Oh, that's interesting. Dave, say more. I'm not quite sure. What's in your imagination about that? Berkman says I'm gonna build another one of my Q lights today or tomorrow. Oh, fun. Been putting off further software development until I had at least one built so I'd have a working one. Yeah, that constant like trade-off of like, do you work on the software before the hardware before the software, and you kind of got to do both at once if you're being good. Add a buzzer or something. That's kind of interesting. Kind of like the old like call buttons on a ClearComm system, right? You could just you need to get somebody's attention, and you just hit call and it would flash or buzz at them or something like that. That might be kind of interesting. Yeah, what other... I'm just trying to, let's think of other pieces of stage automation. I'm thinking back through... I mean, so like flies, like the fly system, or revolve, or elevator, like trapdoor elevator or orchestra lift style thing might be kind of fun. That seems fairly ambitious and also would sort of require developing the idea of a stage floor, right? Like currently now... the quote-unquote micro stage, as I think of it, right, is really everything from, well, with cable slack included, is really everything from here up. The stage part of the micro stage is just other parts of my workbench. We haven't really fleshed out what it means to have a stage floor there. Although that might open up some kind of fun possibilities, right? I'm literally thinking back to the last time I worked at a nonprofit theater as a staff member, like what the automations console that was sitting sort of upstage, what axes did we have run to it? Wagons, we could do stage wagons and do like a motor that pulls them back and forth or upstage, downstage across the deck. That might be kind of fun. If we were getting really ambitious, we could do like a Phantom of the Opera boat that like drives itself around. Although I think even in many productions of Phantom of the Opera, that's just, I mean, not to minimize it, but that's RC car technology, right? You take an RC car and you put a boat on it. So that seems, I mean, it would be fun, but that seems like kind of a solved problem, if you will. Yeah, so like axes of automation wise, and seems too ambitious. I think it was the last summer I was with this last theater company. We did Peter Pan, and of course the fun thing about Peter Pan is he has to fly, which is something that we should all take incredibly seriously. And we did. We brought in a flying company that specialized in human flying, and I could not for the life of me tell you which one it was. It wasn't Foy. And it wasn't Chicago Flyhouse, who is local to us, who was just strapped for time. Like they were booked by the time we settled on our season. I don't remember who it was. But they had their own separate, automation rig and system for. We did one 2-axis flight rig and and 3 single-axis flight rigs. So we had. Now this is a tangent, but that's what you come here for. Over the thrust, the long thrust, we had basically a stick of truss that ran from the proscenium line. This theater, I should say, that I worked at was shaped in a very funky way. It was got a very deep thrust with a proscenium house upstage of it. So it was like, here, where's my view here? So sort of a long, deep thrust, sort of shaped like so, sort of 5 chunks of audience with VOMs in between them. That's a little light to see, I apologize. But you get the idea, right? And then there was a proscenium line here, and then there was a full 24 line set fly house upstage of it with wings and everything. Was kind of funky. Lots of sightline challenges into this upstage playhouse area because of the extreme angles on this seating here. But for Peter Pan, we had a stick of truss above the proscenium line that ran basically on that kind of axis, so Peter could sort of fly back and forth here. And then we had 3 literally just up and down points, 1, 2, 3. So I think in the big song where Peter flies the 3 kids, Wendy, Michael, John fly away to Neverland, Peter got his big track so he could move up and down and upstage, downstage along that axis. And then Wendy, Michael, Peter were on just up and down axes, but they had controllers just below the fly systems. Not controllers, but just like static slip points. So they could go up, but if they gave themselves a little bit of momentum, they could swing or do a little circle or just like have some life to them as well. And this was a super interesting mechanism because it allowed Peter to move independently in 2 dimensions with a clever pulley arrangement. So it wasn't like we had to have, a motor in, say, the catwalks moving a motor that tracked with Peter. It was 2 motors that were static, and because of the way that the pulleys were arranged between each motor and the dog, the mechanism that held Peter along the track, one was still lift and one was still lateral motion, but neither of the motors themselves had to move. It was very clever. It was kind of like the way that some like 3D printer mechanisms work, where you have sort of independent control of your multiple axes with none of the motors themselves having to move. It's kind of interesting. Let's see. Door or window that opens by itself would be cool. Yeah, for sure. And that would be a kind of fun. I mean, for a lightweight model, we could do that with just a servo, right? A hidden servo under a stage. What music would you support when the stage is done? Haven't really thought about like how this all comes together into a queuing system, Francesco, I'll be totally honest. But I guess we'll see when we get there. So there's our circuit board. We've done our through-hole parts. I'm just glancing back over at our slightly out-of-date assembly instructions. Bootloader, code, and final assembly. Okay, we can do that. So let us open our Arduino app. I know you can burn the bootloader through. So I've been doing, on the advice of I forget who in chat ages ago, I've been using the Arduino IDE for years and years, and someone recommended, like, hey, there's a pretty decent plugin for VS Code, Visual Studio Code these days. You should use that, and I have been, and I love it, because I love Visual Studio Code for all of its little foibles. Let's see here now. I don't have a power light here, which makes me think that maybe I have unplugged something accidentally. Yes, I have. I'm going to very delicately plug it back in. I don't accidentally unplug something else, like lose a camera again. There we go. USB tiny, hopefully everything's still fine. Let's see. Brokeboth says, have you thought about a dedicated controller for the stage? Something that's a bit more unique than a generic DMX controller would be nice. Yeah, I have given it some thought. And let me leave you hanging there while I get this bootloader burned, because it's going to be just a little finicky. Let us see. Pro Mini, COM8. Burn bootloader. Error. Let's see here. Burn bootloader. All right, so we'll get this aligned. Burn bootloader. Error again. Yeah, Brookwith, I have considered it, and I actually have a couple of metal enclosures that I've thought about building, like actual control surfaces onto. Now, why am I getting an error here? USB Tiny ISP burn bootloader. My alignment wrong? Maybe I just need to press harder. You can. I have this janky USB pogo pin adapter. Error while burning bootloader. USB Tiny transmit. It's not even seeing. I don't think it's even seeing the USB Tiny. I'm just looking at. Sorry, I'm looking at my my options here. Pro Harmony 5 volts, 16 megahertz, USB Tiny ISP burn bootloader. I think that's right. Let's see here. Just for good luck, I'm gonna power cycle the programmer again because it is a little bit cranky. Error while burning bootloader again. Why? Why would you do this? Let's check my solder joints on my adapter here. They're not great, but they're not any worse than they have been before. Check my alignment. Make sure I have this in the right orientation. I do. Burn bootloader. Nothing. All right. Well, here, I'm gonna tell you what I'm gonna do. I'm gonna with the programmer plugged in, I'm gonna restart the Arduino software. Oh yeah, I could do a DMX triggered Creative Connors interface. Creative Connors does nifty stuff for a really decent price. I do like their products. We used to use them back when I was at Looking Glass Theater, for both performer flying. What is this? Why would you give me an error? USB Tiny transmit SD clock. Burner type USB Tiny. Let's see here. Using port USB. New programmer USB Tiny. AVR dude USB demo and found USB Tiny on bus here. So it is seeing the Tiny programmer, but it's not seeing the actual device itself. Now why would that be, I wonder? Wow, some of these solder joints are just bad. Well done, Jeff. Huh. Well, that's kind of throw. Oh, I was gonna say throw a wrench into our plans. It's got power LED there. I've got. It's interesting when so I don't know if you can see this on camera. So there's a little green power status LED down in there. It sometimes just goes off on its own. I think the device goes to sleep or the USB driver gets confused. This is about a 10-year-old programmer at this point. But I don't know if you can, let me see if I can position it so you can see. When I put the programmer into, it browns out almost immediately, which is strange. I don't know why it's doing that. That is new behavior. And the only way that I know of to reset that is basically unplug and replug in the adapter there. So what I'm going to do, see if I can get this to work, is just basically try and be quick about it and and align this, press it in, and hit burn bootloader right away, and see if I can get this thing to behave. Yes. Yes, bootloader burn! Success! Okay, that's great. So now that finicky part is done, now I can just use a standard FTDI adapter like this guy. Now this one currently has the RX and TX pins swapped on it because I made an error on this particular board. But now, in theory, I can put this on here, and let's give this an address. So I'll need to open Microsoft Office. Let's come in here to the Demilight code. We'll say that this is going to be start address. Let's see, the one we have currently is probably address. I guess we should figure out if we want to address these like the existing truss warmers or no. Probably not. So that's the first, well, you know what, I'm gonna address the lights 1 to 12 and the transformers are 1 to 12, and then I'll split them up at a future time. So let's make this start address 4 after all. And now in theory, because I have burned a bootloader here, I should be able to just upload this over FTDI. It's gonna compile first. Oh, Dave, thank you. Thank you, Dave. Yes. To to recap the muted part. What was I saying? Oh, the whole idea of this setup, right, is that I could use the programmer to burn a bootloader on here, and then in the made-up future where I sell a few of these or put these on Tindy, people could grab them, they'd be programmable via the Arduino IDE, via an FTDI converter, much like you would do with an Arduino Pro Mini or a lot of the other products. That's just going to be a more familiar process for people. But right now, this board is good to go. So let me skip back to my assembly instructions. And let's see, it says I should do a smoke test. I think we'll probably be fine. Center the servos. That'll be our next step. So I'm going to need, I think I have here somewhere, yes, a little adapter that just was going to have power and ground, although that's not where power and ground go. Let's get our screwdriver here. Need a big blinking light for when we're muted. Maybe we do a one-off night that's just like Jeff does the stream improvement projects that have been so desperately needed for so long. Like making, that actually technologically might be kind of fun, right? Because I have done integration with OBS over WebSocket before. In fact, really early on, if you go back to some of the early streams from like March and April of last year, one of the projects that I implemented and I have since struck was a project that I mounted it's a little tiny 5mm LED, little red LED above each of my two primary webcams. And one on the overhead cam, and did like a little tally light system so I could tell which camera was on, and it would basically just read the status from OBS and send a signal out to actually a little Arduino that would turn on the appropriate light. All right, so that board smoke tested just fine. Yeah, that could certainly be. I mean, certainly like. If I were in this for the views, right, doing a thing on stream that's about streaming seems like a no-brainer in terms of engagement. I mean, as I've said before, I'm not really in this for the sake of streaming. I just enjoy sharing some projects with y'all, but it's certainly something to think about. Let's see. Using the Elgato Stream Deck software or Companion could make a button on their blink when you're muted. Oh, that's a good idea. You know, I'm just using the Stream Deck, like the native Stream Deck software. But yeah, having some kind of setting on there that responds to the mute state of the of OBS is probably not a bad idea. Really, at this point, I should do whatever is going to be the lowest barrier to entry, because I've been saying that I need to do this for so long and I just haven't, which means that I've made it too complicated. I think I have centered those. I hope I have. Didn't hear either of those servos move, but I also have the big chunk and headphones on, so it may not mean anything. Next step, solder LED wires in place. Let's do that. I guess maybe I'll just double check which is which. I have these labeled black and brown on here, which if past me was a sane past me, that means black is positive and brown is the negative lead. But let's just do a quick check with the power supply before we go too far down the rabbit hole. Strip a little wire back there. Yeah, so like things that would be fun, like stream quality of life improvements for me, and then like, you know, I feature them and I'll like put plans up for them or something, would be The mute indicator obviously would be would be hugely helpful. The tally lights project I could bring back. Tally lights is just like a film and TV term for an indicator of which light is on, which camera is on rather. Yeah, so that polarity is correct. Yeah, I don't know. So one feature that I have wanted just for chatting better with y'all is like right now. I mean, right now, this is like we're way deep into how the sausage gets made, but also like in some ways the whole thing is about making sausage, right? I just have like the chat on a little monitor up in front of me here, and I can sort of keep an eye on it and see when people say things. But if I'm turned away to like look at the computer or look at the 3D printer, it's really easy for me to miss stuff. One thing I have thought of is like it would be nice. I find like sound notifications for that kind of thing distracting, but like having a light or a blinker or something that would just be like, hey, somebody said something. You might want to see what they said. Would be a handy thing. I mean, maybe it's a subsidiary color to the mute indicator. Like the mute indicator is like a big red raring klaxon that says, "Hey, you screwed up real bad." This other one's maybe like a little green light that just says, "Hey, something neat's going on." Dave says, "It's amazing what colored wire can tell you." Yeah, it really is. Man, I did some crimes, some colored wire crimes the other day. One of my projects at work this week was, it's just story hour on here all the time, but that's, you know what you're in for. One of the projects I was working on at work this week was in the museum. We have a mirror maze, like a maze of triangularly oriented mirrors. How do I explain this? Imagine a grid of equilateral triangles about 4 feet wide on the floor, and some of the sides of those triangles are composed of floor to ceiling in a 12-foot space mirrors, and some of them are open, hence forming a sort of infinity maze through them. There's LEDs in the floor that really accentuate this. The mirrors are really clean, works really well. One of the things that we have as a feature, an educational feature in the maze, is in some of the corners there is what we call an Easter egg, which is if you stand in a specific triangle, sensors on the ceiling above you detect your presence and turn on a light box behind some graphics behind one of these mirrors, and some of them are semi-silvered mirrors. And so, like, if you stumble into the right spot in the maze, the wall suddenly lights up and tells you about, like, Fibonacci numbers or the triangular numbers or symmetries of triangles. It's sort of science integrated with this maze environment. Let's see, I should be probably installing the PCB while I do this, huh? So, like, a really cool way to integrate this, like, learning opportunity with this, like, fun for kids experience, right? And this thing was not working. One of the four was not, and they asked me to take a look at it, so I did. Long story short, it turned out to be an intermittent solder joint on. So I don't know why it was built this way, but it's built with an Arduino. There's literally an Arduino with a custom shield on top of it that is just hanging out in this box, and it's reading 3 distance sensors, like time of flight distance sensors that give analog readings back to it. It's reading those 3 sensors and using that and some relatively simple algorithms to determine, like, is there a person underneath me or not? And if there is, according to the sort of agreement of these 3 sensors, turn on a pin which is connected to a FET, let power flow through, light up this LED wall that has these graphics on it, right? So not a terribly complicated thing. The problem ended up being an intermittent solder joint on one of these FETs. Didn't look like a cold joint, it just looked like a poorly formed joint, which was giving all kinds of weird behavior because it's a 12-volt system, and you could measure 12 volts coming out of the power supply, and when the thing was on, you could measure about 12 volts on the output side when there was no load, right? So the joint was just a high impedance point. But it wasn't an open circuit, so you'd be like, oh, it's floating. I put my hand under the sensor. Oh, now it's 12 volts. Why? It must be kind of working. And it turns out that under load, that voltage fell precipitously because it was basically a FET that had this solder joint that was acting like a resistor next to it. And it was super, super interesting. The point of this story, if I can remember it, was about wire color. So I built a, to try and track this problem down, I built an adapter with a couple of these funky 4-pin locking connectors from TC that this, whoever built this project 10 years ago used. I had red and black wires. Like, this would be perfect. I can use some. It's a low voltage system. I'll use red for positive. I'll use black for negative. Everyone will be happy, including me. And then I realized that the amount of wire I would need to use to get from the sort of the place in the air where this power supply was to the light when it was sitting on the floor for testing was more than the amount of red wire that I had. I should take this screw out and try again. So I had a bunch of white wire, so I had a choice. I really wanted to use red and black for positive and negative for a DC system. What is not fitting here now? Something is strange with this mounting. It's like it's not fitting down like it should. It looks okay. Maybe I was just doing it bad. So it's either I could do. Does one do in this situation where this adapter's only going to really be for me, and it's only really going to be for one day, right? So whatever crimes I do, I can hide pretty well. What's happening here? Oh, you know what it is? Yeah, this is I think, one version old of my base design, and the pillar underneath where this screw is supposed to thread into is not quite aligned right. Yes, and actually, because these should be chamfered as well. You can't see that there. These edges should be beveled, and they're not, and that was something that I definitely fixed. So this must be a slightly old print, but it matches the color scheme for the rest of the prints I'm going to use tonight, so I think that's going to be fine. Just make sure that screw goes in. Just got to force it into the PLA a little bit there, and that'll be fine. So I could either do, God, the stories just take forever, don't they? I could do red positive, black negative into one side of the test point adapter and come out the other side with another pair of colors. And the moral question was, okay, so I'm going to use white and black as positive and negative in this context. Do you keep black as the negative because it's a DC system and black is negative and white is the positive? Or do you pretend that it's now like an AC system and do black positive, white negative? What would you do? I can tell you what I did. I mean, none of these options are good, right? All of this is bad. The right answer is buy more freaking red wire. But I just wanted to get it done. Yeah, Dave, you're right. There's nothing I can tell quickly. Maybe some facts, maybe some light facts, but the stories are long. And what else is long is the roll of VHB tape that I have just here. Good segue. Yeah. Put a little VHB on here to get this servo cover tacked down. Hey, Chris. Is there a repository for the old code on that Arduino? On which Arduino? Sorry, Chris. I didn't see your comment there for a little while, and I'm not sure what Arduino I was talking about when you said that. So a lot of Arduino-y things in the world right now. Labels are great. Yeah, printing on heat shrink. We have a nice Rhino brand printer that does really nice cable labels that you can heat shrink over. That's something that Alec, my assistant at my previous job, really liked. He was and is so much more organized than I am. But he loved heat shrink cable labels. Install base into lid is apparently the next step, according to Jeff, and I trust him. So we'll just mange some of the servo wire in there. We'll move the umbilical over here. The MSI Arduino. So there's Yeah, the way this stuff is archived is pretty variable. In fact, that's one of the things that they've assigned to me is like centralizing a lot of the old archives. We have network attached storage, specifically for the exhibits department that we get kind of full reign and control over. So that's where a lot of stuff like Arduino code for specific exhibits ends up, and that's all backed up to the primary server automatically, or at least it was. I'm told that we're moving to... Sorry, I'm just looking around for my collection of needle files while I talk. I'm told that we're moving to a more online-based system, like a SharePoint or a OneDrive or something like that in the near future, and so probably all of that will be getting pushed to the cloud in some way or another, but you know what's not in the cloud is my needle files. Where are my needle files? I'm gonna need those little guys to get this, oh, here we are. Needle files. Just pull out a little, my little rat tail file here. Maybe triangle file. Just to get my yoke nicely placed onto the servo there. Yeah, the Rhino series of label makers are really quite nice. Put barcodes all over the gear and put them on inventory software. What, out of curiosity, what do you have a feeling on inventory software? It's something else that we've been investigating at the museum, is thinking about how do we manage our inventory, how do we track upgrades and repairs in a more consistent way. I brought up the other day the idea of something I had seen done at University of Chicago, actually the one summer I worked there. And that was, a very much a student-based environment, but literally every piece of equipment in, say, their like lighting and sound booth had a QR code on it and a big sticker that said, "Is this having a problem? Scan this QR code." And it would basically bring you to a pre-populated form in their ticketing system, so that you could, really, really easily put in a ticket with, one of the theater folks that said, the light board is broken or the sound isn't doing or whatever it was. And so I was like, well, this is a great system because we have, hundreds and hundreds of pieces of gear that we have to worry about. Oh, that's backward. Supposed to go to the left so that it points in the correct direction. Wouldn't it be great if our techs, who are always super busy, if they could just walk up to a piece of gear with their phone and scan it in and say, hey, this is down, or hey, this is having a problem, or at least, have it pre-populate the form that makes it really easy for them to finish it later or something. And the point that was made to me, and I think is very fair, is, we work in a public museum, and anything that is accessible to the public, whether it's an exhibit, whether it's a QR code, whether it's the floor, the ceiling, like they will touch, play with, and experiment with. And that's part of the point of the museum, but like it would only be a matter of maybe 15 minutes the first day we deployed something like that before we would start getting, fake tickets from children scanning QR codes with their phones doing nefarious things. And of course, there's lots of ways around that. We could do MAC address validation. We could have logins. Like there's ways of making that more better. I just thought that was a funny point. It's like, oh yeah, they will, kids and adults, frankly, everyone will just get squirrely on these things. Partly because the environment tells them that it's a place to be squirrely. That's part of the point of the museum, is it's super duper interactive. Let's see. Brooklyn says, for theater and events specifically, I like the look of current RMS with a monthly fee. I set up Snipe IT, which is designed for IT stuff. It works for other things too. Yeah, that's kind of the model that I think we're thinking about, is like a ticket-based inventory system or a ticket-based repair system. Have stuff stolen from me in theaters. I've worked to have experienced theft. Always good to know what you have and what you've had in the past. Yeah, and that's the other thing too, is like as we start to integrate a ticketing system more and more with our like, I don't know that we would integrate it with payment tracking, but at least integrate it with like payment requests. So my dream is like, if you're an engineer or a tech, you could say like, hey, here's a ticket from 2 days ago where we said that this, current example, the machine that's running this is blue screening every once in a while. I think it's a problem with the graphics card. Can you order me a new one? Here's the link. And that also goes in the ticket. And then, either automatically or manually, when someone orders that thing, a note goes into that same ticket that says product ordered. And so when this same thing happens 8 years from now, to a computer in a different exhibit that's the same type of machine because they went in at the same time, we can go back through our ticketing system and be like, this looks off. What did we do last time this happened? Oh, right, we bought this thing and it worked. Or we bought this thing and it didn't work. Just having that kind of documentation on hand would be super useful. And of course, like, all of that information exists in emails and purchase orders and the oral history of the place. And it works pretty well. Like, that's a common system to a lot of places, right? The knowledge of how things work exists in people's emails and in their receipts and in their brains. But one of our dreams is to start moving toward a system where, like, there is some more concrete institutional knowledge around these things. That we can really, especially, if we're onboarding new people, if we're, needing to cover for somebody else's area. We have nominally 20 techs on staff, or 20 tech positions at least, and so it's not uncommon on any given day or week for someone to be like, hey, I'm calling out sick. It's like, okay, well, who's going to turn on U505 today? Who's going to turn on Body Worlds? Who's going to turn on Science Storms? And if there's atypical stuff in there, if we want to have any chance of someone who's not, the regular U505 person fixing something, we have to have some kind of real documentation of what's been done to fix stuff in the past. And honestly, like, the day-to-day stuff is kind of less of a worry than, like, the week-to-week stuff. Like, we had a situation last year, for example, where we had a tech go out on, like, long-term medical leave. Like, needed to, not worth going, like, tech needed to get a surgery, went out and got the surgery. Awesome. Tech's going to be out on medical leave for, like, 4 to 6 weeks. Awesome to be working a job where that's totally fine. But it's also like, if something breaks week 1 and only this tech knows how to fix it, we're kind of SOL. Like, we'd like to have that documented a little bit better. All right. Well, there we go. That is assembled. Probably need to put a little bit of VHB on there as well. What did I do with the VHB when I put it down just a moment ago? I put it on my desk, and it's right in front of me here. Let's see. Snipe IT contrasts purchase costs, deprecation, repairs, checkouts, current RMS tracks rentals and employees too. Yeah, it's something we kind of are looking for, something like that also has like a very much an IT ticketing type system integrated with it. So you could, like, raise issues with errors and assign them to a particular tech, or assign them to a project or a project manager. So anyway, this is all just speculating, but I think something like that would be an interesting thing for us to have. Hey, it's another little light. Isn't that adorable? Let's get him hung on the rig. Just gonna plug a couple of our, let's see, I'm gonna want this to be oriented like so. So let's do 1 and 2, and we'll hang him on second electric here. Well, that was pretty painless. I mean, modulo a little bit of strangeness getting the bootloader loaded and that cover falling off there. Maybe I need to adjust the tolerancing on that. And should have waited a little bit longer for that VHB on that cover to set. But yeah, another light in the rig. That's awesome. Well, neat. Well, I feel good about that. So having done that, well, let me hydrate, and let me remember to unmute after I hydrate. And by hydrate, I mean enjoy this delicious official hazy India Pale Ale from Bell's Brewing Company. And then let's get into thinking about mechanical systems, because my dream of like, well, we'll like solder this thing together while we talk about ideas for that, it's kind of fallen apart because I realized I want to like sketch while we chat about these ideas. So kind of a 2-part evening, but that'll be. All right. So let me grab some sketch materials here. Wow. Let me grab some chaos as well. All right, let's take just a second to figure out what the right layout and camera and stuff for this is. I think this is going to have to tilt up a little bit here so we can actually see a little bit more. That's pretty good. Yeah. If I were to go to the table, you can kind of see most of this. Maybe I'll zoom out just a little bit more. Yeah. Hey, Thomas is back. Thomas, we just finished assembling another light for the rig. I was just saying to these folks how my idea of we would talk about the mechanical stuff while soldering the thing kind of fell apart because I wanted to draw while we talked and I couldn't get my brain to quite work that way. So now we're going to talk about what is the next side project in Demilight land. And so here's what I'm thinking as far as here. Let's make a quick list. We could do a is that readable hoist and chain lift or something like that. We had revolve. We had automated door or window system. Elevator was suggested. We're just going to put fire over in its own little box over here and kind of wall it off from the rest of the ideas. What else did we have? We had, we could do a flying actor system. That would be really ambitious, but it might be kind of a fun project. Let's see, what were our other inspirations here? We could do something with audio was a suggestion. That might be kind of fun. Let's see. That was kind of our main one. I think other stage automation axes. We could do confetti drop, which kind of feels similar to the Kabuki drop, but might be kind of fun. Gosh, I do have stories about confetti drops, but we'll get back there at some point. Yeah, lots of interesting possibilities here. Let me wrap at you what I'm thinking about. I don't know what I last used this sheet for. It's all kind of scratching there. What I'm thinking about for a lift mechanism. Sort of did the audio on Halloween. Oh, that's right. Yeah, we made the pumpkin person, who I think has gone. I think he has gone the way of the rest of our jack-o'-lanterns and is gone now. So one of the things in thinking about the process of making motorized flybar and batten, because it has a very existent. Yeah, for sure. So that here, I'm gonna make that a subcategory of lift and chain hoist. Flybar or batten system. Snow, Chris, that goes down with confetti. I feel like is the snow drop, because I feel like those two things go hand in hand. So for any of these, we're probably going to need, for a lot of these, we're going to probably want stepper motor control, right? So we have really precise positioning of these things. Here, let's start a little features list. Maybe I'll get a different color because I like different colors. Maybe we do, so things to think about. Stepper motor control, thinking about limits and limit switches will be a thing for a lot of these, right? So any of these that's going to have an axis of travel that's not self-regulating like a servo motor is going to need some kind of limit or at least positional finding. And some, as I think about this, so some systems that have what are nominally limit switches have hard limits or soft limits, but there are pieces of hardware we use like an IQ for those who've used them, which is just a goes in front of an ellipsoidal fixture. This is your ellipsoidal fixture pointing up. It's a little device that just has a movable 2-axis mirror in front of it. So it turns your ellipsoidal into a tiny little scanner light. The light comes up, bounces off the mirror, and goes out. And you can sort of pan it left and right and tip it up and down. Those actually, I think, don't have any limit switches in them at all. They just, when they boot up, if you ever turned on an IQ, you'll know it makes an awful sound when the first time you apply power to it. It goes. Sorry for those wearing headphones. It goes. And that's literally just, it slams its servo motor into a hard stop over and over again just to make sure it's actually hit that stop. And then it assumes that it's at the end of its travel in that direction. And then it's like, okay, well, if that's all the way left, say, now I'm at center. And that's all it does. So it has no limiting switches at all. It just sort of rams into a hard stop. And we could do that for some of these less critical axes. I mean, obviously, you wouldn't do that for like an elevator in an actual stage situation. So yeah, do like a Source 4 Mini and a Source 4 Micro and an IQ Micro. I have thought about doing a Source 4. So they make Source 4 Minis now. We have a ton of them at the museum because they're a great museum fixture. Do like a tiny IQ for a Source 4 Mini. That'd be super cute. And who knows, now that ETC and City Theatrical are more closely together, what with the like multiverse product line that they announced this week, maybe they'd want to invest in a tiny IQ. Who knows? Probably not, but it'd be kind of cute. Let's see. We'll have some mechanical things to think about with each of these. It'll be a little bit different, but like, for example, the elevator probably needs rails, or vertical rails or guide rails, which will be a new thing to think about. Oh, Chris makes a good point. Yeah, the Prusa series, at least the Prusa Mini, I assume the Mark IIIs as well, are they find their limits through current limiting, I believe, because there's current sensing on the trinamic drivers that do the axes on those. It basically just drives the stepper motor over until it hits its end stop, and so the current spikes. It says, okay, well, the current spiked there, so I must have hit something, so that's my limit on that side, and then same thing on the other side. We'll probably have to think about hinging if we're thinking about doors and windows, like hinges and automated trap doors is a fun idea. Traps. That kind of goes with, let's say, traps and lifts, which is, in my mind, are slightly different from an elevator, but really are the same thing. That would be fun. That might be a fun excuse to like think about like a pin pull system. So we kind of talked about this when we were like sort of roughing in what a Kabuki drop is, but a lot of systems, right, have fingers to hold your curtain and a pin that just prevents them from falling, and something pulls that pin out and allows the fingers to drop. And something like a trap door could operate on a similar system that is a sort of a pin pull and drop. So you're hearing my phone go blippity bloop in the background. So that would be kind of fun. The confetti and snowdrops are probably the easiest, at least the rigs that I have seen. There's a variety of them, but a lot of them are just a big perforated drum that spins and allows something to fall out of it. That would be honestly, that would be a pretty easy adaptation from the Micro Kabuki. If we were to swap this servo out, modify that servo to be a continuous rotation servo, and just mount a drum coaxial to that shaft, that's basically, that's a snowdrop right there. That's pretty straightforward. Actor flying, that's ambitious. That's going to be for later. Tiny actors. Yeah, the idea of an automated trap would be cool. It'd be quite small, but it would be kind of fun. Well, let me wrap you a little bit about safety mechanisms for lifting things, because this is something I just learned this week and I think is really quite clever, which is how the brake mechanism in something like a chain hoist or a brake hoist actually works, because this is something that I feel like we could potentially implement in a 3D printed system, which would be part of the dream of this would be to make as many parts of whatever we end up making 3D printable as possible. And you know, I have come to recognize the value of, like, for something like a pipe or batten, you know, a dowel or brass rod or something, I think that was definitely the right choice for something like this. But in thinking about creating a mechanism, the more 3D printable for my purposes, the better. So inside, so many of you have interacted with a chain hoist before, I imagine, but just in case anyone hasn't or hasn't in a while, the thing that we're thinking about is, and they make motorized and manual ones, but they work the same, which one of them has a motor on it. Something like this. Yeah, there you go. So it's got a lift chain, and then it's got a loop of chain that is your control chain. So you grab one end of the, wow, that's just quite a mess. Open image in new tab, open image. There we go. So, so you basically grab your loop of control chain, and if you pull it in one direction, the lift chain goes up. If you pull it in the other direction, the lift chain goes down. If you let go, the chain doesn't go anywhere, right? That's the idea. And so, The up is easy, the down is where it gets clever, right? So oh gosh, I have not planned how I'm going to draw this at all. Maybe I should do it in pencil. Maybe that's the less ridiculous option, if I have a decent pencil. And if not, we'll just do it in pen, and we'll all figure it out together. I took so many of my mechanical pencils to work, I actually don't think I have a decent one here. That's pretty funny. I'm diving so much into my work life these days. That's pretty great. So on the upside, think about drawing this in isometric on paper. Let me think here. Let me do it in 2 steps. So let's start from the user input side. You can all see that, I think. Yeah. So we have our input wheel. In our manual case, where our control chain would be. Right? And this could be a motor, this could be a hand crank, this could be a control chain. That's just, that's your input side. Is our input wheel there. And what we're ultimately going to want to control the position of is our output shaft. So let's add that now. Our output shaft. And in manual chain motors like these, there is almost always a significant gear reduction ratio between your input and your output, right? So a lot of them it's 25-to-1 or 30-to-1 or 50-to-1. So you pull 30 times as far on your chain to pull with 30 times as much force on your load chain, right? So you pull and pull and pull and pull, and your truss or your whatever you're lifting slowly raises up. So to prevent this from let's on our output side, we just have our load chain here, and it has a hook, and it's got some Acme style comedy weights hanging off the end of it there. And the slack for this chain usually just collects in a little chain basket, a little bag that hangs off of a hook on the motor there, right? So as the chain goes up, it goes up and over our output coupler here, and then just whatever excess just pools in that bag. Let me make sure I'm getting this right and draw a couple of guidelines while I do. Let's see. So So the output, make sure I'm getting this right, is directly coupled or coupled through a gear ratio to, for example, on a lot of these motors, it's a washer mechanism that's welded solidly to this shaft. Yes, Wile E. Coyote and Roadrunner will be taking their places just underneath the weight down here. So this is a fixed connection to, say, a washer plate. Next to that is some kind of brake pad, cork or a synthetic rubber or what have you. We'll just fill that in because I've screwed up the perspective already. So this is a brake pad, and so this is a fixed washer. This is a washer that is fixed. This is a brake pad which is floating. Right, so it is concentric with this shaft, but it is not actually attached to it. Then you would have a ratchet mechanism, which, God, I'm not going to be able to draw in this kind of perspective. Jesus, that's rough. And then you might have another brake pad. And then you have your input. And these 3 things are all floating on the shaft. And a lot closer together than I've drawn them here. These would be right snug up next to each other. So this is our ratchet wheel, and this is another brake. And this ratchet wheel has a pawl, right, which is the element of a ratchet if I draw it in a separate drawing down here, right? If you have a ratchet wheel, the pawl is the thing that prevents it from turning in one direction. It's the little hinged piece that slips down into the ratchet. So this wheel could spin in this direction because the pawl would slip over the angles of the teeth, but it could not spin in the opposite direction because it would get caught on the backside of those teeth, right? So in this case, this is the pawl, and this is what I'm calling the ratchet wheel, although I don't think that's quite the right name for it. The cog wheel, potentially. And the really clever bit is that this input, whether it's a hand crank or something you manipulate with a chain, or a motor in our case probably, whatever this is, at least in the model of hand manipulated things, is actually not fixed to the shaft either, but is connected via a threaded coupling. Right, so the end of this shaft is itself threaded, and the interior part of this input wheel or crank, whatever, is also threaded. So what happens is, if no force is being applied to the input, and we just have some load, in this case we have 1 ton of load on the output, to make sure that we don't crush our friend Wile E. Coyote down here, who's very sad. What we do, right, so if this load is static here, the shaft is going to want to turn in the opposite direction of the pawl. Basically, when we forced back in this our case, the clockwise direction, that will be locked. The pawl will prevent the shaft from turning, the load will not fall, and everything is sort of in stasis. If we want the load to move up, we pull on our input cables, or turn our crank in the direction that causes us to move, in this case, the yes direction, causes us to move in the direction that the wheel is allowed to spin, which is the up direction. Right, so when you crank up a chain motor, you often hear an awful like click, click, click of that ratchet spinning as the load lifts off. And then as soon as we stop lifting, the ratchet falls back into place, the pawl catches it, nothing moves. So you can lift and lift and lift, but as soon as you stop, the load is caught by this pawl. It's the down direction where things really get clever, right? Because with this pawl in place here, you'd think like, well, if I try to turn this wheel the opposite direction to lower the load, how this pawl is going to catch it is just going to be in the way. But that's why this floating mechanism is clever. When this wheel moves in the opposite direction, in the downward direction, the threads on the wheel will unthread it, will thread it in such a direction that that wheel actually moves out along the shaft just a little bit, just enough for this ratchet mechanism, which you'll remember is also free and floating on this shaft, to become loosed and start to spin on the shaft itself. Right? And once that's free to spin, we are able to move our load downward, right? So why doesn't the load just fall? Well, let's say we pull in our downward direction, we loosen up this wheel here, the ratchet starts to spin, the load moves down, which turns the shaft, which actually tightens this wheel back up against the brake, right? So our downward motion is still going to be proportional to the amount that we move our input direction here. It's only going to be able to continue as long as we are actively moving our input, whether it's a chain or a crank or whatever, to allow this mechanism to separate just a little bit. These rubber brake pads to separate from the ratchet mechanism, provides a little bit of flex in the system. This moves down, tightens back up, and stops. Right, but as long as you maintain a continuous motion on your input side, you'll get lowering motion. A really clever system. I hope I've made kind of a mockery of it. But the gist of it in writing is up on the input side means that the ratchet is engaged and load goes up. Down on the input side means the ratchet is disengaged and the load moves down. Pretty clever. Like I said, this is the thing I learned about this week in anticipation of thinking about this project, and yeah, fairly straightforward and clever, and there's not a lot of points of failure in it, which I like. So, one of the key points of thinking about a 1/12 scale like flying hoist or truss system, right, is that if it loses power, the things can't fall, right? That should be true of any hoist system, really. But thinking about, as we saw on the Micro Kabuki rig last week when we were doing final testing, when the controller reboots and the servos, move to their position, sometimes it would just drop the curtain on its own because its power off behavior was somewhat undefined. And I would really like, if we're going to go through the labor of designing a lift system, so more or less from scratch, that it have at least the property that if you turn off power or you reset the controller, whatever it's holding doesn't fall to the ground. And this is, I think, a sort of the simplest mechanism that achieves that while still being able to move in one direction or the other. And then we could potentially add in the middle here gear reduction. just to reduce the amount that we'd have to amount of power we have to provide to raise or lower our mechanism. Although depending what our actual motor source is, what our thrust is here, that may or may not be necessary. Anyway, Dave, to your point, I have no short stories. All the stories are long. All of them are involved. But I don't know. I got excited when I read about this because it feels like a thing that would be implementable, right? And this could be something like 3 or 4 different 3D printed parts, right? We would have something like, we'd have the shaft with its integral washer and its integral threads would be one part. We would have the ratchet wheel would be another part, because that has to be free. These are probably the brake mechanism, the thing that actually is providing friction, is probably not 3D printed, right? That's probably some kind of like rubber washer or gasket from the hardware store, I imagine. And I guess actually, depending on if we're clever enough, the output side of this could also be integral to the shaft, maybe in draft 1. Or we think about breaking this in 2. I'm just going to grab color after color. I own these freaking Sharpies. I might as well use them. If we're going to end up implementing some gear reduction black box in the middle here, some planetary gears or what have you, then this probably becomes a separate part at the output side of that gear mechanism versus the input side. So the shaft, and then whatever our input coupler is, whatever this project's equivalent of the Thomas coupler is, to couple our stepper motor into our shaft is another thing. So we have the shaft, we have the ratchet, we have the input coupler, we have the output shaft, and we have the gear reduction mechanism. And I'm really excited for that breakdown, because the shaft should be a relatively straightforward drafting job except for the threaded end, and that'll be kind of fun to figure out. The ratchet mechanism also should be, I guess we'll also, what we'll have? We'll have the pawl. That'll be a part of this mechanism. So the ratchet and pawl will be fun to figure out. I've actually done a little bit of tinkering with ratchets and pawls before when I was into 3D printed timepieces for a hot second there. The gear reduction will be kind of fun. See if we do like a funky planetary gear thing might be a good time. Output shaft should be relatively straightforward, although we will have to think about ultimately like what is this actually, what is this and what is this? Is this a chain lift? Is this a drum-based rope winch? Is this, what does this actual lifting surface look like? I haven't really gotten there yet. Yeah, I will, Thomas, I assure you, I will use D-shaft motors with little set screw couplers of some kind onto them. Yeah, that seems the only sensible way forward, given the choice to start from scratch. So I think I will. Yeah, I think this is going to be a fun project. And as I look at this and think back to our project list as to things that might be reusable in an interesting way, right? Because one of my goals in Hobbyland is to think about each project not only for like what it is good and fun for, but also what skills and materials does it bring to my arsenal of problem solving. And so like things like the Demilight projects were great for like, I practiced and got better at not only like PCB design, but I got super familiar with various aspects of the microcontroller and with the particular LED drivers I was using. So now like that LED driver is just a stock part for me. Like, oh, I'll just throw that in a project again, or I'll throw this power supply at the project again. So looking at this, if we were to complete this, right, some of it's awfully specific to this project, but this sort of assemblage of a brake, ratchet, and pawl I could totally see being useful to us in future things. I think we'll learn a lot about this gear reduction mechanism as we go. Whether that's directly applicable to anything else, I think we'll see. And then I'm sure there'll be implementation details on the mounting and usage of like this output coupling, which will be fascinating. So yeah, I think this will be a fun thing to do. And, once we have a motor which drives an axis sort of safely in 2 directions, that locks when it's not moving, like I think that mechanism is relatively straightforwardly translatable to something like a miniature elevator, right? Just the load looks different, but it's a similar idea. Revolve, probably not quite the same thing, although once we have stepper motor control under our belts, that should be relatively straightforward. Confetti and Drone Top, like I say, we'll see if we get around to those, but those we could certainly implement. And things like traps and lift we could certainly integrate there. Thomas says, got designed into a corner with the 0.9 degree pancake steppers with the right impedance for the mover. Were only available with a plain shaft. Yes, and could not get them in D shaft. That is a real shame. I'm so sorry, but soldier on. I believe in you. Yeah, that will get you. Yeah, so I think this has some possibility. And then as far as power source, I guess one of the trade-offs that we'll have to make, right, is the trade-off between like how powerful our power source is versus how much gear reduction we need. Because so the kind of loads that I imagine we're supporting is something like, you know, a what is this, 200 millimeter stick of D3D truss. You know, maybe it's half a kilo, right, of total load with the truss and everything. Maybe it ends up being a full kilo when everything's said and done. Maybe. So, like, I feel like there's a world in which you could pretty easily lift the entire weight of that with something like, you know, a chunky NEMA 17 stepper motor, and then have 0 gear reduction. Right? So we could add bulk on this side for simplicity over here. Or do we want to go with like a little, you know, micro stepper over here and have a fairly significant gear reduction setup? I don't know. My impulse, as I say it out loud, is to start with, number 1, big motor, simple mechanism. And then number 2, we miniaturize it. We do small motor with gears. Right, we work in the direction of just throw power at it to start, get the thing working, and then work our way back toward like a more complicated thing that's more power efficient and compact and small. I think it would be a lot of fun. Yeah. So that's the next plan. In addition to like ordering all the parts that we discovered that I was out of this evening. But I think in terms of what Gollum would say, I think this is actually a pretty good idea. I mean, maybe it's not a good idea. But not a bad one. I think it's certainly got some possibility. So yeah, with a good brainstorming session and with another light added to the rig, which the cabling is a mess right now, so I'm not gonna bother to fire up. We'll save that surprise for next week. But I think that's where we're gonna wrap it up for the night. Thanks for spitballing these funky ideas to me, y'all. I think. Listen, and also I mentioned earlier, like I don't want to step on Cookie's toes with this project. I'm just excited about it. If anyone out there wants to get in on making any of this stuff, like none of this is precious. Like go for it, and I would love to see what you're making. Thomas has been great about tweeting interesting parts of his miniature bigature lighting, which is super fun. Chris sent me some things the other day. I would always love to see what y'all are doing out there. Easiest way to get to me is on Twitter, honestly, at Jeffers Glass. You can try calling 815-0-Malort, depending on how my power supply is doing on any given day. It may ring, might go to voicemail. Information on the Demilight project is at jeff.glass/Demilight, and build instructions are there as well. Yeah, this has been a great night. I think we're just going to wrap it up here. Thank you very much. Be well, wash your hands, be safe, hydrate. For the love of God, hydrate, get some sleep, and I will see you next week. Thanks, y'all.